In this lesson, we're going to look at examples of empirical probabilities. Empirical probabilities simply mean that we are going to compute relative frequency approximations based on some gathered data. We cannot use the classical definition because we cannot assume that all outcomes are equally likely. So we gather data and we use the numbers in the data as our approximations of the probabilities for the entire population. So here we have a table that looks at 5,348 original smokers who then tried to quit. After 6 months, they were looked at to see if they were still not smoking or if they had continued to smoke. So what we have here in the table then are those smokers who tried to quit using either a nicotine gum or a nicotine patch, and then after 6 months whether they were smoking again or still not smoking. So first question, what's the probability that someone in this table was originally a smoker? Well, we just said that everyone in this table was originally a smoker. So that would be 5,348 out of 5,348, or 1. The probability is 1 because that's a certain event. Another way we could have done this is to simply click on the cell 5,348 divided by 3,048. Alright, next problem. What's the probability that from this table somebody is not smoking after 6 months? Well, the total number who are not smoking after 6 months is 469 out of the grand total of 5,348. So 0.087696. How about the probability of not smoking and tried to quit using the gum? Well, this here is an and problem, and when you're working with a table like this, a two-way table, and problems simply involve finding the cell that is at the intersection of the mentioned row and column. So we're looking for someone not smoking, so we're in the not smoking row. Also looking for those who used gum, so we're in the nicotine gum column. And the intersection of not smoking and nicotine gum is the 252 who were not smoking again after quitting with the nicotine gum. So the probability will be the 252 out of 5,348 to get 0.04712. Let's look at a similar problem. How about not smoking and try to quit with the patch? Well, those who were not smoking and tried to quit with the patch, there are 217 of those. So we go equals the 217 out of the 5,348 to get 0.040576. Let's look at a different type of problem. The probability of not smoking given they try to quit with the patch. So given means we know they try to quit using the patch. If we know they try to quit using the patch, we are only interested in this single column. We are no longer interested in all 5,348. So of those who try to quit with the patch, there are 2,367. Of these 2,367, the number who are still not smoking is 217. So the probability of not smoking given the patch is the 217 divided by the 2,367. And that gives us 0.09167. Let's look at another given problem. These, by the way, are called conditional probabilities because we are given a specific condition. In this probability, we want to find someone who tried to quit using gum given they were smoking again after the 6 months. So the condition we are given is that they are smoking again. So of those who were smoking, we see there are 4,879 who were smoking again, and of those 4,879, 2,729 tried to quit with the gum. So we get 2,729 divided by the 4,879 to get 0.559336. Let's do one more of these smoking given problems. So this one, given the condition try to quit with the gum, and that is opposite of what we did before, where we wanted to find gum given smoking. Now we're going to do smoking given gum. So we know then these individuals tried to quit given using nicotine gum. So 2,981 tried to quit using the gum. Of those who were still not smoking, that's 2,729. So the probability of smoking again given using the gum was a 2,729 divided by the column total associated with gum of 2,981. Notice how when you have a conditional probability and given a specific condition, your sample space is shrunk to the single given column or row. It is no longer everyone in the table, so you will no longer be using the grand total in your denominator. You will be using either the given column in your denominator or the given row in your denominator. Now let's look at some OR problems. Recall that OR problems require use of the addition rule. So we're going to need to add. So here we want the probability of smoking or use the gum. So of all those who were smoking, we see there are 4,879. All those who used the gum, we have 2,981. But notice when we add all those who are smoking with all those who used the gum, we counted this 2,729 twice. So we would need to subtract that out. So we go equals all those who are smoking plus all those who try to use the gum minus those we counted twice. We have to subtract out what we double counted. And now we will simply divide by the grand total because we are focused on the entire sample space again. So that's 0.9594. So the main thing here is to avoid double counting. You want to avoid double counting, so you have to subtract out what you counted first. Of course, you can just avoid double counting in the first place and just add up all those who are smoking or gum individually. So let's see. So smoking, we get, in parentheses, 2,729 plus 2,150. For the gum, we already counted the 2,729, so just add in the 252. So let's see. So then plus the 252, and then divide that by our grand total. And there was a mistake. Let me do that again, because I had messed up earlier when I was clicking. So we get the smokers. We have 2,729 plus 2,150. Plus, we need to get all the gum. We already counted the 2,729, so now we need the 252. Close that, divided by grand total, and there we are, the 0.959. Now, let's do another OR problem, and this one will be the probability of not smoking or try to quit with the patch. So, everybody who was not smoking, 469, plus everyone who tried to use the patch, there we go, 2367, but we've double counted this 217, that was in the same row and column, those who used the patch and were still not smoking, so subtract that out because we double counted it, and then divide by the grand total to get 0.489716. Or we could do this problem just avoiding double counting in the first place. So not smoking, 252 plus 217. Now we need those who use the patch. We already counted the 217, so we bring in the 2150 we haven't counted yet. Close parentheses, divide by the grand total, get the same answer again. So this is just some quick examples of how to find probabilities using a two-way table And so this is gathered data, and we call these empirical probabilities.